Hello guys, this class is in continuation of your earlier class. We were armature type relays. Okay, and again we also came to know that this is the electromagnet which attracts this armature which is going to approach towards left side when I actuate this coil by operating quantity called current as well as voltage. And again when it operates it gets attracted and this is pulled up and this is connected to trip circuit, so both these contacts will get closed. Okay, so the force of attraction of this electromagnet towards armature is given by F is equal to K times I square, where I can be written as I max sine omega t whole square. Whereas again if I if I resolve this formula, then I can write this formulas in this fashion. The first component is constant and the second component is variable pulsating, as it is applied for AC purpose. Anyhow we know that this type of relay works for both AC as well as DC, but first component is for DC and second component is for AC. So now I was telling about the modified hinged armature type relay, right? Why we need to modify this? Because if I use this type of relay without any modification, then such type of relay will become very much noisy and you will get to see humming sound. Okay, so in that case we need to what? Modify this electromagnet like this, that is by doing shaded construction, so that what happens, by doing so we can reduce the humming sound as well as noise. Here you can see that electromagnet is provided with two coils. This is the one coil and this is the second coil. Okay, so here one coil is energized with the actuating quantity, here you can see, right, and the other coil is supplied through a phase shifting circuit. This is the phase shifting circuit, this is the second circuit. So again by doing this, so what happens, some amount of humming noise as well as humming sound as well as noise can be reduced. Okay, so such relays are very fast in the operation when compared to that of induction, disc and cup type of relays. Its operation time is around about 5 milliseconds. Okay, and again these hinged armature type relays are compact in nature, robust as well as reliable in nature. Okay, and these are also affected by transients, like I told you, transients in sense what, switching whenever we switch the such instruments or any equipments, or during any turning on turning off, or it may be due to the lightning and all, so transients are easily get introduced in the circuit and they are fast. Such relays are fast as well as they operate for both, like I told earlier, AC as well as DC. Okay, so this is what we have with the hinged armature type relays. Okay, and one more thing, here one thing you should see over is the VA burden. Like I told you, burden means it is a product of voltage as well as current at the secondary side wherever the load is connected. Here it is low. Okay, and around 0.2 watt for this relay is consumed. Very less burden is there for such type of relays. Okay, second type of the relay is plunger type relays. Here you can see the plunger type relay in this figure 2.3. It's the casing of this plunger type relay, and this is the one which is called as solenoid inside of this casing. And again this is the iron rod plunger, it's also called as plunger, and here you can see these are the contacts and this is the spring connected to this is the any reference. Okay, see, always the spring is pushing, that is pulling from top to bottom, means it is pushing always downwards if no any supply given to the solenoid. Clear? So the spring always pushes towards downwards so that these contacts are open, right? So as soon as I give supply to this solenoid valve, what it does, so this solenoid gets energized, and due to the electromagnetic attraction, so what happens, this plunger is pulled inside so that the force is greater than that of the force exerted by spring. So when it is plunger is pulled inside, so what happens? These contacts were open before, now they are closed. So by this way the plunger type relay works. Anyhow, such type of relays have become obsolete, like it is told here, it draws more current. So such types of relays we don't use. Obsolete in sense what? They are used very less. Next comes the balanced beam type relays. Let us jump to the figure. The figure 2.4, it has been shown, that is balanced beam relay. You can see that there are the electromagnets, and this is the horizontal beam, and again it is balanced. So the name balanced beam relays. Okay, in the normal condition this beam will be horizontal, okay, and it is balanced in nature. So you can see two electromagnets are there. One electromagnet, that is IR current flows in this, which will provide restraining torque, whereas I0 flows in this electromagnet, which provides exerting torque or operating torque, you can call. Okay, operating torque as well as restraining torque. And again, like I told earlier, during normal conditions, this horizontal beam will be truly horizontal without any moving downwards or upwards. And you can see this armature is movable, where you can see at the center we have pivot at the nail. Okay, pivot. Now when restraining torque as well as operating torque, if they are same, then what happens? The horizontal beam will be constant without any moving. If my operating torque here, if it is greater than that of restraining torque, then what happens? This you can see, this is the armature which is movable at the center, so it is pulled downwards. This armature is pulled downwards. You can see before it was, the contact was open. Now after getting pulled downwards, this contact will get closed. Okay, so now what happens? Whenever this happens, whatever, depending upon the circuit design and all, it will trip the circuit, or trip or make the circuit, or it may send a trip or trip signal to the circuit breaker. Okay, if used directly. Okay. Again, this beam is controlled by a control spring, which you can see over here. Okay, so whenever your operating torque is greater than the restraining torque, then what happens? This armature gets pulled downwards and these contacts are closed. And again, if contacts are closed, depending upon circuit design and all, it will send the trip signal to the circuit breaker. Okay, so again, such type of balanced beam type relays are now obsolete. Before, such relays was popular for constructing impedance as well as differential relays. Okay, nowadays they have been replaced by rectifier bridge comparators as well as permanent magnet moving coil relays. Okay, and anyhow, this beam type relay is robust and fast in operation, so it requires only one cycle, it seems. But since it is not accurate, as it's affected by the DC transients. Okay, so this is what information we have with this. Advantages also we have, disadvantages also we have, since it is not accurate, and when it comes to the speed, it is very robust and fast, like it is told. Okay, so these are the things with respect to the balanced beam relay. Okay, now let us study about moving coil relays. There are two types of moving coil relays, namely rotatory moving coil as well as axially moving coil type of relays. At the first, let us look at the rotating moving coil relays. Okay, so here you can see the figure. There is a permanent magnet in this shape as well as a coil assembly. Okay, the components used here, as this is the permanent magnet, already told before, a coil which is wound on the non-magnetic former, that is iron core, as well as there is a phosphor made bronze spring to provide the resetting torque, Okay, whereas there is a spindle, okay, as well as jeweled bearing for easy moving purpose. This moving coil assembly carries an arm. You can see this is called as moving contact, which is at a distance from the fixed contact. Usually it is open. And also damping is also provided for smoother operation. Again here in this moving coil relay has operating time of around 2 cycles. Okay, so whenever operating torque is greater than that of the torque produced by the spring over here, then what happens? This moving contact will move along with the coil. So whenever this coil is energized with so and so current as well as voltage, so what happens? Here this moving contact will start to move from right to left, that is in the anti-clockwise direction. Okay, because the operating torque is greater than that of the torque produced by the spring. So finally what happens here? Still the operating torque, if it is greater than the restraining torque or torque produced by the spring, these two contacts will get close, and depending upon the design, it sends the trip signal to the circuit breaker. Okay, so usually such types of relays are very fast in nature, and they are having very VA burden very less, very small, and they have around sensitivity of 0.1 milliwatt, so very accurate. And these relays are costlier than that of induction cup or moving iron type relays, as we have discussed. Okay, so again induction cup and everywhere, that is moving iron type, will be discussed in detail in the coming classes. But as of now, just remember these such type of relays are costlier than that of induction as well as moving iron type of relays. And again one thing you should remember, these relays are only meant for DC purpose, means this relay will response for only DC. Okay, and you can apply AC, just if you have the again rectifying circuit and all, then you can use with the AC quantity also. But actuating quantity is DC, it should be DC. Okay, let us see the second one, that is axially moving coil type, the figure 2.6. Okay, here you can see is the axially moving coil, which is horizontal. This is the fixed part, whatever you are seeing, this is the fixed part, and this is the moving one. And again here it is more sensitivity than that of rotatory moving coil type relay we just now discussed. Okay, and again it is more faster as the parts here are very light, and again it has sensitivity of as low as 0.1 milliwatt. See how very less, and also its operating time is around 30 milliseconds. Within 30 milliseconds it will operate. Here you can see the coil is wound on the cylindrical formant. This is a cut shape here. So actually basically it is a cylindrical formant which is suspended horizontally, and the coil is wound upon this. This coil will move only axially, that is from left to right or from right to left. And this relay is also having inverse operating time characteristic. Depending upon the actuating quantity and all, what happens, this relay is pushed from left to right, so that the trip circuit gets close. Okay, this is pushed here if the coil is energized. Okay, and again such relay is very delicate in nature as the gap is very small, so it should be handled very carefully. Okay, and again when the coil is de-energized, again what happens, again it is pulled back. Okay, so this is free to move horizontally from left to right depending upon the current flowing in the coil. Okay,